Hello guys, I'm back. Today I am here to talk to you about cost estimation for chemical process engineers. Stay with me up to the end to learn what is cost estimation, what engineering documentation are needed to do cost estimation. I will cover a case study for the installation of a two-stage compressor so you'll see how to fill a cost estimation summary based on that. And finally, I will show you how to activate the cost estimation option on Aspen HYSYS. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Before I start, let me share with you the following disclaimer. I am a chemical process engineer with expertise in plant design and I am not a cost estimation engineer. To be a good cost estimation engineer, it requires specific knowledge and specific skills. That is not my case. However, as I work with chemical process engineering and plant design so long, and as you proceed in your career, it is expected that you get familiar with project management and also cost estimation. And currently I work supporting a cost estimation engineer in the projects of the company. So based on that, my main purpose here is to let you familiar with this discipline. That said, what is cost estimation when we think about chemical process engineering and plant design? In a few words, cost estimation is the prediction and assembly of the amount of money needed to do a project. Before installing a compressor, installing a propylene plant, a hydrogen plant, or a air separation unit, the company will perform a cost estimation to verify if the amounts of money needed to do that project in comparison with the expectation of profits makes sense or not. So based on that, the cost estimation engineer uses different techniques to do the cost estimation. We, as a chemical process engineer in plant design, we are responsible for the first selections of equipment and process, and that influences the work of the cost engineer. So based on that, in my point of view, it's very important that you get familiar with this discipline because it will help you to perform better your job as a chemical process engineer. The cost estimation can get different classifications depending on the stage of the project. The key documents for defining these classifications are the process flow diagram and also the piping and instrumentation diagram that in general are responsibilities of the chemical process engineer. However, these classifications is not absolute and depends on the institution that are being considered. For instance, according to the Association for the Advancement of Cost Engineering, a cost estimate can be divided in 5 classes, and these classes ranges from class 5 to class 1. And from this table, you can identify that as higher is the class number, less accurate is the cost estimation. So if I consider that I am in the concept screening, not too much of the project is defined. In fact, eventually there is no project yet, it's just verifications and studies. The amount of money expended can vary from minus 50% of the cost estimation up to 100% of the cost estimation. If we are talking about one project that the cost estimate results in a 100% currency, in the end, the amount of money expended can be 50 currency or can be 200 currency, because this is the range of the cost estimation. The cost estimation engineer will define what is the level of accuracy for each cost estimation based on the information available. For class 5, the definition of the project, the primary characteristics for defining the class is the percentage of complete definition, and as we have here from 0 to 2%, most often the cost engineer will use as methodology the capacity factor, parametric models, judgment, or analogy to define or to estimate what is the amount of money for those projects. As the project proceeds and we have more information and engineering documentation is issued during the project, we can have a higher accuracy in the cost estimation. So when we go from class 5 to class 1, now we have around 50% to 100% definition of the project. It's possible with the documentation developed do check, estimate, and bid tender, and the accuracy can be as low as -3% in the lower range and plus 3% in the higher range. And there is here, of course, that depending on the available information, it can vary from -10% to plus 15%, and verify that it is much lower in terms of range of accuracy than in the class 1. So between class 5 and class 1, we have class 2, 3, and 4 that is defined based on the percentage of complete definition. This is not the only reference that you can use to do the cost estimation or to verify your cost estimation. If we take into account the Project Management Institute, they are responsible for the front-end loading methodology for project management. Here in this table, we can verify that depending on the gate or the front-end load number, we have expectations of cost estimation also. So if we compare or do analogy for the AACE, you can verify that FEL1 is in the business domain and it's very similar to the class 5 in the AACE. So in this case, the cost estimation will vary from -50 to plus 100. And if we proceed in the gates, it means that we are defining the project, we are doing the documentation for the project. In the front-end load tree, that is the documentation, the detailing engineering documentation for issuing the engineering, procurement, and construction, we can get cost estimation as low as -5% to plus 15%. And we are able to do that because we have a detailed scope, the process flow diagram is issued, the final version, the pipe instrumentation diagram has the final version, and we have also execution plans. So based on that, there are different classifications for cost estimation, and those classifications helps you to identify what are the accuracy of your cost estimate. If you are in the early stages of your project, of course that the accuracy will not be as high as if you already have the engineering documentation done to do the procurement of the proposals. And talking about the engineering documentation needed to do the cost estimation, let's take a look on that. Returning to the EECE recommended practice 18R97, you can find a table with the correlation for the engineering documentation, the project management documentation, and the class of estimation or the cost estimation class of a project. As we have discussed, as earlier is your project, less definition are available, and because of that, your cost estimation has a lower accuracy. So in this way, when we are in the class 5, there are this recommended practice, the definition of the project ranges from 0% to 2%. So we will have mainly the project scope definition, because it's not possible to do a project without a scope definition. How you will be able to perform something if you don't know what must be done? And in terms of engineering deliverables, eventually you will have the block flow diagram. And the block flow diagram is a document responsible of the responsibility of the chemical process engineer, where you will define the major units of your project or eventually the major equipment of your project. And as the engineering deliverables are issued, the cost estimation engineer is able to refine the cost estimation and get a more accurate results. And this table here, you need to read that in this way. Considering that you have this engineering documentation available, you are able to reach Class 1 cost estimation. You will not define that the cost estimation is Class 3 and you will do the documentation. You have the documentation and your cost estimation can reach the class defined here. So as we go to Class 1, it's expected that the definition of the project is already around 50% to 100%. So because of that, we have the process flow diagram, utility flow diagram, and others documentation needed. And verify that some documents here, like mechanical discipline drawings, electrical discipline, instrumentation control, civil structure, can be in the preliminary stage, or they can be a preliminary issue, because this point here is considering the basic engineering or the front-end loading design engineering. When we go to detailing design, engineering, procurement and construction, these documents here must be completed in order that we can erect the plant. You will not erect the plant with preliminary drawings, or you should not erect the plant with a preliminary drawings. Of course, that during the construction, changes may happen, and you will issue in the end of the project the as-built drawings. So with this table here, it's possible to do a prediction or to evaluate what kind of class can you reach with your cost estimation. If you have only the block flow diagram, it's impossible to have a cost estimation as accurate as Class 1, because you don't have the engineering deliverables available. And this is very important because the project management or the board of your company most eventually are not familiar with the methodology, and they need a number. The business team wants a number to know if the project is feasible or not. Depending on the person that is asking you this number, they don't know what are needed to get this number. So here you have a reference to show them what are needed to have a cost estimate as accurate as possible. Something to take into consideration when we are doing cost estimation is the contingency of the project. As we have with the range of accuracy, the contingency will decrease as we proceed to the end of the project. Because the contingency is there are many definitions for contingency, but in a few words is the amount of money that you save for risks that you know that may happen, or for risks that you don't know that may happen. For instance, let's suppose you do a cost estimate for equipment and you ask for a quotation for the equipment, so you have a higher accuracy for those equipment, but you will not buy this equipment right now. Your project is still in development, in verification, and eventually you will be able to start it in 6 or more months. So because of that, you will add a contingency for the equipment in order to try to mitigate the risks of having your project authorized not now but in 6 months, for instance. If you are in a place where your equipment must be imported, for instance, you can have the risk of the importation taxes. It can increase, it decreases, the dollar can be higher, can be lower. So because of that, you can consider different contingencies for different aspects or different kinds of capex or costs that you have in your project. So based on this paper here, the cost contingency as the standard deviation of cost estimate, we have here also a reference of how much contingency can be considered depending on the class or the level of cost estimation of your project. Here we have the concept screening that is class 5 and class 4, 3, 2, and 1. So as the class of your cost estimation decreases to goes to one value, you already understood it is possible only because the engineering documentation needed to support this cost estimation is already available. So as you reduce the risks, you are able to reduce the contingency from 50% in the earlier stage of your studies up to 5% in the end of your studies, where your definition of your project is around 50 to 100%. So this is the international suggested contingency. But the paper also share with us another index, another reference. So based on that, we have a variation that ranges from what we have here in the international suggested. So if you have the opportunity, I recommend you to take a look in this paper. So based on everything that we have seen up to this point, now I am able to share with you a case study where we will see how to fill a cost estimation sheet for the installation of a two-stage compression. So guys, now let's see how to connect the theory with the practice, because as you know, I am here to teach students, graduates, and engineers how to work with chemical process engineering and plant design. So imagine that you work as a chemical process engineer in a small petrochemical industry, because in small companies, they don't have a cost estimation engineer to perform the cost estimation. Most often, this task or this job will be performed by other engineers, including the chemical process engineer. So a wet waste gas rich in methane is available at the defined pressure and temperature, and your boss asked you to do a cost estimation to compress this gas and deliver it as a defined pressure. So you need to issue a cost summary with preliminary capex and also opex for this case. To be able to fill the cost summary of the project, you need to understand what kind of costs are associated with a project, and also you need to understand what is the problem. So the problem is to install a two-stage compressor in an industrial facility. And what kind of costs are associated with that? You have two main kinds of costs. You have the operating costs and you have the capital costs. The operating cost is the cost related to the operation of the machine. So in this case, two-stage compressor. It will only happen when the machine or the equipment is in operation. And you have the costs associated with the capital. To install a two-stage compressor in a facility is not only a matter of buying the equipment. The equipment is only a part of the project, of the cost of the project. So big projects or small projects, most often they have the same structure. The values will differentiate between them. If you are talking about $20,000 million project, the distribution of the costs will be different than talking about $100,000 project, but the steps or the kind of costs associated with that will be mainly the same. So here I get a reference from the book Estimativas de Custo de Investimento para Empreendimentos Industriais. Is a Brazilian book so I don't have a reference in English to give it to you. But what is important from this table here is that we have an expected distribution depending on the kind of project that we are talking to. For big projects, 20 million US dollars project, most often the distribution of the cost will be similar to this one. So I have a small part of the cost associated with the feasibility study. I have some part of the cost associated with the engineering, basic engineering, detail engineering. I will have a major part of the cost associated with the project for the equipment, purchase of the equipment, and I have the bigger part of the cost of the project associated with the construction. Here I included the material needed for the construction, and after that phase, or after that kind of cost, your cost associated with commissioning startup decreases. It's lower than cost with equipment and construction, and you need to have a contingency that will depend on the phase of the project that you are doing cost estimates. Here, let's consider that we are in a class 5 cost estimate, so we don't have too much definition. It's around 0 to 2%, and based on that, I will fill the cost summary to have a distribution similar to that. It will not be equal to that, but it will be similar to that. I expect that I will spend more money with the equipment and construction than with engineering and commissioning, for instance. And here, just to remind you about the disclaimer, this class here is for cost estimation for chemical process engineer. I am not a cost estimation engineer, and I am not preparing people to be a cost estimation engineer. If you don't know what to do when your boss asks you to do the cost estimation of something, or if you want to propose improvements in the process, but you don't know how to collect or how to define the amount of money that will expended for that, here I give you at least a direction, and that is my main purpose here. So based on that, let's go to the spreadsheet. I will start filling the cost summary spreadsheet by the OPEX tab. In the OPEX tab here, as I'm talking about a rotating equipment, I expect to have some kind of energy to be able to operate this equipment. So let's suppose first that I need electricity to run my compressor. How I am able to estimate the power consumption of this equipment? Based on the scope definition, you can perform hand calculations to verify the power of your compressor, or eventually you can use a process simulation software like Aspen HYSYS to build or to simulate the two-stage compressor and verify what is the amount of power needed to run this equipment. So based on that, I built the two-stage of compression with the first stage, cooler, another stage, another cooler, and I will get these results and transfer to my summary cost spreadsheet. In this case, we are doing preliminary calculations. I am not worried if the polytropic efficiency of the compressor is 80% or 75%. It is only the first values that I want to achieve to fill the cost summary. Remember that when we are in the class 5 cost estimate, we can have a variation as higher as minus 50% and plus 100%. As you develop the calculations, you will be able to get the results, talk with the compressor vendor and get the quotation and refine the results. That's not the case here. So if you don't know any information available how to perform or how to estimate the cost of energy or the amount of energy needed to run the compressor, you build a process simulation and verify what is the amount of power that you get from your process simulation. Remember to consider the amount of power needed as shaft power for the rotating compressor, and also the amount of power needed to have the cooling of your stream. The heat power or the heat flow is different of the mechanical power. So make sure to not summing up things that are different. You need to transfer the energy power or thermic power to shaft power in order that you can have the power consumption, the estimation power for the power consumption. So once I defined what is the power consumption of my equipment, you need to verify what is the cost of energy per hour of your electricity, for instance. So here, what I have here in terms of currency is just the multiplication of the power consumption I have by the energy cost, and I need to know, or I need to evaluate how is the availability of my equipment. The availability of a facility or equipment is the time that the facility is available for production. In this case, I am considering that at 95% of the time, the plant will be running. Although we want that our equipment is 24 hours running per 7 days of operations, in fact, we need to do maintenance, we need to do, there is some kind of trips, so you need to take into account that in order that you are doing your calculations. So based on that, I defined an availability. If I consider that it is 100% available, you verify that my energy cost will increase. So if eventually for the preliminary calculations, I can consider 100% because the cost with power will be higher. In this case, I don't know yet if my compressor will be lubricated or not. Most probably it will be lubricated. So I just estimate some values here in terms of oil replacement. So it's a handle value. General maintenance, I also add a handle value. And of course that if you are in an industrial plant, you have people that works with operations, you have people that works with maintenance, and you will never do your job alone. It's impossible to have all answers, and you will need to ask for some help to get some information. And that, for instance, the cost of the lubricant you can get with the procurement, dollar considered, or the currency conversion considered in the project you can get with the financial team, and etc. So in this case, what's important here to you understand is that for the operation of the compressor, what kind of consumables I will have? I will have electricity, I will have oils and lubricants, and I will have general maintenance like shifting of filters, strainers, etc. So based on that, I can estimate what is the amount of money that I will expend in terms of month or in terms of year. Once I did that, now let's go to the feasibility tab. The feasibility tab here in this case is the amount of hours that I will expend to do this evaluation. In plan design, every project that you work or every activity that you do must be associated with a project because we are paid based on man hours produced. If you are in a production, in the industrial facility, eventually you don't need to do the timesheet of your working hours. But in plan design, you always must do that. So here, even though this project do not go ahead, as you are spending hours to do the verification, you need to consider how much it will cost. Instead of planning, or instead of verifying if it's feasible to have a compressor in your industry, in your site, for instance, you could be doing other things for your company, like verifying the performance of the plant or any other activity. So the feasibility tab here, the main purpose is to evaluate how much costs to verify the feasibility of this project. So in this case here, I just consider that a self-employee will do the verification 60 hours, and the way to estimate the hours, you get more skilled once you do that more than one time. Here I added an imaginary value of 35 currency. So if I multiply the number of hours by the main hour, we have the cost that is associated with the evaluation of this project. Eventually, depending on the kind of the project, you will need to hire consultants. Usually, consultants has a main hour value higher than self-employees, or you will need to hire or contract engineering service, and they may have engineering hour, a main hour higher than consultant, that is higher than employee. Now, considering that we will proceed in the other stages of a project, we need to fill the tab engineering. In the tab engineering here, I have divided it, and you can organize it the way that is better for you. So I have the disciplines here that I considered as will do the fiscalization of the documentation provided by the basic engineering company and detail engineering company. So here, as we have a very small project, I'm considering that the basic and detail engineering will be done by a third-party engineering company. We are talking about a facility without an engineering department. So even though I don't have an engineering department in my company, I need to have people to do the fiscalization of the work of the engineering company. So in this way, I am considering that I will have some consultants or some personnel available in the facility. For instance, the guy from the maintenance will need to verify the engineering documentation, because in the end, when the project is installed, he or she will be responsible for doing the troubleshootings of the equipment. So I have to consider the main hours for management, coordination, planning, documentation management. It is very important. During the project, I will receive documents from the engineering companies, and I will receive documentation from the vendors, suppliers, and etc. So in the engineering tab, the main objective is to list what are the disciplines associated with the project, how many hours they will expend doing verification or doing the execution of the project. And in this case here, I added the engineering companies for doing basic engineering and detail engineering as a third party, with the summing up of the how many hours needed to perform the project. With the main hours, the number of hours, I have the total amount of money for each discipline, and there are some projects that you must consider the travels. You need to go to another site to verify how is done, how they do that kind of job, or you have another facility, or you need to go to the vendor to verify the equipment, you need to visit the engineering department. So based on that, I recommend you to add also a column for travels. In this case here, I didn't consider any travel, but you will estimate how much is the cost of the travel, and based on that number of travels, and with the total main hours, you will have the total cost for each discipline, and you will have also a distribution in terms of percentage of costs for the disciplines. That will vary also, depends on the scope of the project. So up to this point, we are talking only about documentation. And now let's fill the tab related to the equipment. It is in the tab related to the equipment that I will list all the equipments needed to the installation of the two-stage compressor. So I will have one compressor, and the value related to the compressor can be estimated in many ways, as we have seen during the presentation. So here I know that I have a similar compressor in another facility, and I have the quotation of that compressor. So I added the information from the compressor here to my table. However, I don't know how much was the spare parts for this compressor. So based on that, although I have a quotation for the compressor and I added the information here, I estimated the value of the spare parts. Every time that you buy a rotating equipment, you have the pieces of the equipment will lose their life during that time. So it's normal that we buy some stuffs for the replacement of the pieces that is not more with the performance in the equipment. So this is the spare parts. So based on that, I did the estimation of the spare parts as 5% of the total cost of the equipment. Here, as I am in Brazil, I know that my equipment is imported, is from another country, so I need to take into account to my project, because the project will be paid in local currency, not in euros, not in US dollars, so I need to convert all the values for the local currency. And in this case, I consider the value of the currency conversion. If my proposal is in euro or is in US dollars or other currency, I need to convert that to my currency. And I also added the importation fees, because the supplier or the vendor will give you the cost of the equipment most often at its origins without any fee. This fee here is fee related to my country. How much costs to bring the compressor from Germany, for instance, to Brazil. So this is the importation fees that I added to my calculations. So I multiply the cost by units, by the number of units, and I have the local cost of my project. Same with the spare parts, because it's coming with the compressor, and the compressor is imported. Now let's take a look in the construction tab. What kind of service and costs I have associated with construction? I don't know about the construction, so what I can do is do some estimations to verify how much the construction will cost to me. I need to consider that I will have civil engineering related to this scope of supply or this project. So at least eventually we'll need to do the base for the installation of the compressor. I will have mechanical scope here, because I need to have people to install the compressor. It will come to my site. I need to use trucks or some kind of lift to let the compressor at the place where it must be. I need to do the installation of the pipelines, bolts, etc. I have as a rotating equipment, and I need to supply electricity to this equipment. I will have a scope related to electricity, so there will be cables, illumination. I will have the electrical panel of the compressor, and I will have also instrumentation, because I will have set points for alarm, shutdown, isolation, and based on that I will have instrumentation cables, I will have the instrumentation panel, and the instrumentation installation related to people needed to do the cables in the place and etc. So in this case here, I just added some values to summing up 1 million currency. And finally, I have the commissioning startup. What are the people needed and what are the stuffs needed to test the compressor and let it safely run to operate? So the main purpose of the commissioning is this: doing the tests in the equipment to let it safely available for operations. So in many cases you need to consider that the vendor will do some kind of assistance, and most often vendor main hour is the highest hours that you find in your project, but I will need also to do verifications and checklists related to electricity or electrical issues. I will need to do verifications and checklists for instrumentation and automation. You can add, for instance here, a line for the process engineer assisting with the verifications and checklists. And in this case, I will multiply the number of hours by the main hour of each discipline or each professional that will be working in the commissioning and startup of the system, and with that I will have the amount of money needed. Summing up all these tabs, I will get my cost summary. So in the cost summary, I will have the feasibility study and the total amount of that, and it will represent a percentage of the total cost. I will have the engineering here. You can see that in this case it is 0.3% of the total amount. The equipment, in this case here, I don't have hours associated with that because in this case I am purchasing equipment, not engineering. And in this case I have 73% of the total cost is associated with the equipment. That cannot be this value in the end, but makes sense, as I am talking only about just one equipment to be installed. I can expect that the major cost will be associated with the equipment. The second major cost will be installation, because I will need to do civil engineering, electrical engineering, mechanical, instrumentation, automation. I will need multiple persons or many people to do this. So this was estimated, or the calculations performed give to us as reference 16.4% as the total cost. I have the commissioning startup here that is very low in this case, and I have the contingency that I forget to show you. So I have the feasibility, engineering, equipment, construction, commissioning startup, and I have the contingencies. The contingencies here, in this case, I divided it by discipline. So for feasibility, as I'm doing the job, I eventually, if it will be more or less, it will not be of too much importance. So I consider the contingency as 0. It will be what it will be. The engineering, I can consider that based on my estimation, based on the how long it will take to do the feasibility study or others information from the economy. I have here 5% of contingency. Equipment, I get this quotation from another site, so it's similar but it's not the same. I added a contingency of 10%. Construction, I am not familiar. I don't have enough information for all engineering deliverables, so 15%, and in commissioning startup I added 7%. These values here, guys, is not covered in ROC. It's just a reference. For each project, for each stage, for each location, you will have different index to assume. As I told you, my main target here is to let you familiar with cost estimation. You will need to study a little bit more to verify what kinds of index will fit your needs. Eventually, you will find some references, and I believe that you can start with this, or as we have seen in the beginning of this, or during this presentation, for class 5 cost estimation, you can consider, for instance, that it will be 50%. Of course, that if you consider that it is 50%, the numbers will change. And when you return to your cost summary, you verify that the contingency here is 33% of the total amount. It makes sense or not? By my experience, do not make sense to have a contingency higher than the construction and close to the equipment. The contingency is something that is to mitigate the risk. So something around 5 to 15% at the early stages, considering the total amount of the project, makes sense. But it's up to you to verify how to deal with that. And in the cost summary, I also added the cost of OPEX in terms of month. So what will happen here if you are working in a company that has the business team and the engineering team? The business will get the information related to the cost, related to the OPEX, and they will perform the feasibility, the economic feasibility of the project. How is the present value, how is the tax of return, and etc. based on this information here, and most often they will ignore what is inside the other step. Of course, that it depends from company to company, how big is your company, but it is the way that I have seen in some situations. You can see that the cost summary of the example is very different from the table that we have here. That is not an issue. Each project has its specifics. And in that case, I filled the main hours for each discipline, for commissioning, startup, and etc. So another way to do cost estimation from scratch, if you have at least the information of the equipment. In the example, the only reliable information that I have there, let's say that is the quotation of the equipment. I had a quotation of a rotating a compressor, two-stage compressor, similar with the conditions that I want to. So I can, for instance, use that value as my basis, and based on that, do the distribution of the other costs in my cost summary. This is another way to do for the preliminary cost estimation. Again, this is only to let you familiar. Each case in the real life, you verify what makes sense or not. Before showing you how to activate cost estimation on Aspen HYSYS, let me emphasize to you how is the cost behavior of a project. See here that we have the phases of the project here divided in conceptual, detailed, procurement, construction, and operations. And it's normal in any project that you expend less money, and this is an accumulated cost. So you expend less money during the engineering phase of your project, and when you get into the procurement, that is the purchase of the equipment, you have a big increase in the cost accumulation, because now you are expending more money in your project because you are buying the equipment. As we have seen, in the equipment are one of the biggest percentage of the cost of a project. And when you get into the construction, it is also a major cost of your project. So you keep increasing the cost accumulation until you get into the commissioning, startup, and operations. So based on that, if you build your cost estimation, and most often to the board or to the project manager, you need to have also what is the cost in the timeline. We didn't talk about that, but you need to have the cost in the timeline. Your curve of cost will be this way. And at the right side, you can see the influence of decisions in terms of cost, or influence of design decisions, and based on the conceptual, detailing, procurement, construction, and operations. What it means: any kind of decision that you do in operation will not influence this design, because the design was already done. So in the conceptual design, your decisions make a great difference in the design decisions. When you go to the detailed design, you still have time to modify what needs to be modified in the design. But when you get in the procurement, you will do some adjustment based on the information of the suppliers, but it falls drastically what can be done in terms of project. So in the construction, now you don't have any influence in the design. Of course, that in the end of each project is a good practice to have a lessons learned meeting. So if a lot of things happen during the construction, during the startup and commissioning, startup and operations of the plant, you will get this knowledge, share with the team, and with that, when you proceed to another project similar or the very similar or analog for the project that you have been worked, you now can anticipate problems, and you can, during the conceptual and detailed design, have the correct decisions to avoid the risks related to the problems that you faced in the construction and also operations. Now let's talk about cost estimation on Aspen HYSYS. The Aspen Tech has a tool for cost estimation that is called Aspen Process Economic Analyzer, or APA. This tool is connected or is integrated in the Aspen HYSYS, so based on your process simulation, the Aspen HYSYS and also the Aspen Plus are able to do the preliminary cost estimation of your industrial design. To activate that, you just need to check this button here. So the capital, the green bar here, and we'll see that on Aspen HYSYS based on the process simulation that I performed for the two-stage compressor. And to do all the calculations, the Aspen HYSYS follows 5 steps, where there are the setting up of the model for process economics, and will not get into the APA, but it can be used also as a standalone software. There is the mapping unit operations to process equipment, the sizing, defining process equipment, evaluating costs and investment metrics, and viewing and analyzing results. So when you activate the cost estimation on Aspen HYSYS based on what is available in your process simulation, and it must be converted, the Aspen HYSYS will verify its data bank and will give to you a cost estimation based on the CapEx, what is the purchase of the equipment. Will give to you also OpEx based on the consumables of your system, and will give to you also a cost breakdown. So let's take a look on Aspen HYSYS. So guys, as I have shown to you, let's take a look how to activate the cost estimate on Aspen HYSYS. That is very easy. Once you have finished your process simulation, you just need to click on this button here, turn on, And Aspen HYSYS, based on what object is available in your process simulation, will verify the data banks and perform calculations related to costs, not only capital but also operations. So here you can see that the capital is $5.5 million and the utilities, the cost with utilities is $240,000 per year. And this green cycle here means or represents the major capex of this system. So the three major capex of the system is identified by the Aspen HYSYS. It can be configured. So when I click in the tab, the Aspen HYSYS will open to you what is being considered. So going to the summary, we have information related to the total capital cost, total operating cost, the total utility cost, the desired rate of return, percentage per year, and equipment cost, and total installation cost. See that the total cost or the equipment cost is not the same as total installed cost, because as we have seen in the spreadsheet, we need to consider commissioning, startup, we need to consider construction and others costs that is included in the equipment or in the project. Navigating by the tabs, you can find the utilities considered. For instance, in this case, the compressor, the intercooler in this case is air compressor, the electricity, there is the amount of electricity considered based on the process simulation. If we go to unit operations, it will list each equipment that is available in your process simulation with associated costs in dollars. So equipment costs, installed costs, equipment weight, installed weight, utility costs. There is the equipment that is basically the same here, because this is a single equipment with a single unit with multiple equipments. There is the TIMA exchanger here, so it is related to the heat and shelving tube. It's related to the heat exchanger. And verify that to be able to do the cost estimation of the heat exchangers, the Aspen HYSYS must perform calculations to that. So here we have a shell tube heat exchanger with BEM configuration. There are some information related to the design, gauge pressure, design temperature, and etc. Verify that there is no detailed design of the heat exchanger, but there are some assumptions done by the Aspen HYSYS. If we go to centrifugal gas compressor, there is here some considerations also. In fact, is a summary of the process conditions of the equipment. Here, the aftercooler is air. If you want to, you can change to water, for instance. The drive type you can choose also. It is a motor, turbine, gas engine, and etc. So I will keep as motor. And finally, you can go to vessel, vertical vessel, and here the Aspen HYSYS do preliminary calculations also to perform the cost estimation. You can send all those information to the Excel. So if you click here, you can choose what kind of information you send to Excel, and with that perform the evaluation that you need to. I will don't do that. I will return to the process simulation, and here I want to share with you some considerations related to the Aspen Process Economic Analyzer. The first thing to consider before using the Aspen Process Economic Analyzer is to set its database. First thing that we have seen is that the values informed in the software is in US dollars in the US. when we consider that the project will be installed in anywhere outside the US, the values or the cost estimation will be different. The second thing is that you need to verify what is the accuracy of the results. The Aspen HYSYS performed the calculations for each piece of the equipment, resulting in $1.7 million for this rotating equipment, for this compressor. In fact, when we get the quotation for the supplier, I will not have each piece of the equipment separated. I will have just one block, just one skid in this case. The value that I have shared with you in the spreadsheet is a quotation of a real equipment that is around $550,000 US dollars. So there is a big differences between the results from the process simulation and also the results of real life. But in that case, the compressor is a reciprocating compressor. So when you change the technologies of the equipment, the price of the equipment will also change. Another thing to consider is the utility summary. You see that the cost of electricity in the US will be totally different than the cost of utility in Brazil, then will be different in India or in Italy, Germany, in Russia, and etc. So to use the APEA, it can for sure let your life much easier for cost estimation, but you need to work in the database of the software. And to do that, you will require specific knowledge because it's not a simpler task. It has a standalone software. It has a totally different interface than Aspen HYSYS and Aspen Plus, and it's possible to set the fittings that are needed, but you need a little bit of time to understand and do this. So this is important to understand before just letting on the cost estimation in your Aspen HYSYS. With this, I have covered all the topics that I want to share with you, and answering the question, should chemical process engineers be familiar with cost estimation? In my point of view, the answer is yes, especially if you work on medium to small companies, because there you will not have a cost estimation engineer to help you. In many cases, you will be responsible to doing the preliminary cost estimations to verify if it makes sense or not implement or to propose some kind of improvements in the process. Of course, that no one in good sense will ask a chemical process engineer to perform the cost estimation of multiple $1 million project. That's not the purpose here. The purpose here is that you are able to work with chemical process engineering in plant design, and when you are increasing or you are proceeding your career as a chemical process engineer, it's expected that you get more familiar with project management and also cost control or cost estimating. So this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.